All right, this will be the instructional video for Chapter 11, Section 5, which is the volume of pyramids and cones. Remember, now that we're in volume, we're dealing with three-dimensional, three-level, or something cubed as the measurements for all of it. So let's start right off with a pyramid. Let me see if I can draw one fairly quickly. Here, well, you know what? I'm going to go ahead and restart that immediately because I've got to do it like this because those are the sides that cannot be seen. And so here's the base. This will be a rectangular based pyramid. There's going to be the top. You can kind of see because of where I drew it that back little section is hard to see. But that's okay. It doesn't have to be perfect, guys. All right. Couple of things to note. The formula is volume equals 1/3 the area of the base times the height. The key here is what the height is. Please notice this is not a slant height. In fact, I'm going to change colors here and redo this one. If you remember when we did pyramids before, we had a bit of a triangle within the pyramid created here, but the height is this one. If you're doing surface area, you use the slant height there. That's the slant height L. We're not going to use that. We're going to use the height in the middle. And then you also have to use the area of the base based upon whatever it is. In this case, because the base is a rectangle, this one would be volume is equal to 1/3 length times width times height. Okay, and length times width being the area of the base and the height being this H right here. All right, now where it becomes a problem for students is when you get a pyramid that is a regular polygon. For example, when you get a pyramid like this that has a pentagonal or hexagonal base. Let me think of the best way to, let's do this one. So this one is intended to be a hexagonal base. So here's going to be our top. There's the back side. Whoops. Back there. Side here. Let's go and take it all the way out there. And erase a little bit of this so we can see it all. And then we've got the front too. So there's my pyramid. Luckily, guys, you won't have to draw this. You'll just be given it. But let me switch colors. And here's my height at a right angle. And then guess what this is here? That's my apothem, okay? Because that's coming from the center of my regular polygon, and it might be used here. And so my overall volume here is going to be 1/3, 1/2 PA with a lowercase a and a capital P. And then added on to that the height, which is represented here. So there's my H, there's my apothem. My perimeter is based upon all of those sides times 6, and that gives you an estimate of how you would find it. So I'm not going to actually do a problem. I just wanted you to look at the possibility. I think you can figure it out by the previous things that we've done. Now, similar to that is the volume of a cone. Just like prisms and cylinders to go together, because prisms and cylinders have two bases. Same thing with pyramids and cones for volume. because pyramids and cones both have one base. It's just that a cone has a circular base. So let me switch back to red here, and let's draw a cone. So there's my cone. The volume of my cone, just like the other, is going to be 1/3. And then you've got the base times the height, but the base we know is pi r squared times the height. So in this one, you're going to see this height right here coming straight through. It goes to the center and it's at a right angle. And it's also going to have that radius. So the radius is there, the height is there, and that's how you'd find the volume of your cone. The only difficulty that you may run across is when you get oblique cones or pyramids. I just need to give you a brief definition of what that height is going to be. If you do get an oblique cone, which looks like this, let me draw one. Here's my cone on the bottom, and here. Notice that the top of the cone is not over the center. So here's an example of an oblique cone. You can kind of see it's a little bit at the side. Let's see if I can get that to go a little bit further out. Well, look at what happens with the height in that circumstance. The height is going to be still at a right angle to the base, but it gets pulled out of the center. And so you'd have to just watch to see where that is. Beyond that, though, guys, that's all you need is 2 new formulas and the understanding that if you get an oblique prism or cone, you just got to be a little bit careful that the height is used and that height has to be perpendicular from the top of the cone or pyramid, perpendicular to whatever the base is. All right. 11.5 is going to be the Math Excel assignment is going to be due on Thursday at 4. Look soon for 11-6, which gets away from new formulas and just goes into a bit of, it switches over to areas and volumes of spheres. So we're going to go away from pyramids and cones, prisms, and cylinders and go into spherical objects, and we'll see that. Have a good week, guys.